American desert. A vast, desolate space. A land of extremes, where survival is by instinct and life itself can hang by a thread. But nature is not the only force that has left its indelible impression. So has man. It's here where some of his fiercest creations are born, tested, and discarded in a venerable boneyard, a junk heap of metal, machine, and ragged glory. One special aircraft narrowly escaped this fate. It was never fully commissioned by the Air Force, but was one of the most advanced tactical fighters the world had seen. Designed to be the fastest, smartest, and the most lethal, and for a glorious moment, it briefly flew over the land where it now rests. This is a factual account of human ingenuity, pride, and sacrifice by an elite team which designed and built this seemingly invincible weapon, and who only recently have been granted clearance to discuss their work.
We were trying to make a fighter airplane be invisible.
A small bunch of people in an isolated environment set off to pursue an adventure. That's what the YF-23 was.
Northrop Corporation's YF-23 Black Widow II has been highly classified until now. The Cold War. 25 years ago, the threat of mass destruction from a nuclear holocaust was possible and quite probable. With two superpowers embroiled in an invisible conflict of arms escalation and air superiority.
At that time, we had that fearsome potential adversary. There was a very real possibility that we would find ourselves in a terrible shooting war against an extremely heavily armed adversary in the middle of Europe.
With a 4-to-1 military advantage belonging to communist forces in Eastern Europe, there were legitimate concerns for the West's defense systems and to the region's political stability. Thomas V. Jones was at the time CEO of Northrop.
The competitor, of course, in military was the Soviet Union. And they had a lot of good design teams, many of them, working on fighter airplanes. The Soviets could develop fighter airplanes that were capable of defeating ours in the sky. And that was enough for the Air Force to say, we better take a bold step forward with the next airplane.
While the aging American F-15 Eagle held on to a slim advantage in controlling the skies, the potential threat in the air by a swifter Soviet-built fighter like the MiG-29 and Su-37 posed a massive problem. If it was to counter the threat from the east, the United States and its aging air fleet needed a shift in aerial strategy. The first plan of action was the gathering of intelligence and spy information to analyze the threat.
And the threats at that time were long-range, very capable ground defense radars and ground defense missiles.
Through an agency known as DARPA, or Defense Advanced Research Project Agency, the development costs to counter the threat were shared between the government and America's aerospace industries. DARPA's main priority was to implement the force multiplier concept.
A force multiplier is any technology that permits one man to defeat 10 men.
Steve Smith is the former program manager for the Advanced Tactical Fighter program at Northrop.
To give a single pilot the power of 10 other pilots, he had to be aware of the other enemy first and shoot first.
The Pentagon's ultimate strategic goal became low observability, the ability to fly undetected, now known as stealth.
Low observables became the mantra of the force multiplier technique. The B-2 was going to go in and attack bridges and other transportation nubs to prevent the tanks from coming forward into Western Germany. The advanced tactical fighter was to take out their interceptors who could attack.
The Pentagon's plan was in place, and the race for air superiority shifted into top gear. In the early 1980s, the Air Force began a concept development investigation, requesting proposals from the leading airframe companies for design concepts for an advanced tactical fighter, or ATF. In 1983, 7 companies responded, but only 2 proposals were chosen by the Pentagon. In 1986, the winners, Northrop and Lockheed, were contracted to develop 2 prototype aircraft which would compete in a fly-off for a multi-billion-dollar government contract. The Pentagon also encouraged the other bidders to team up with Northrop or Lockheed. For 50 years, Hawthorne, California-based Northrop had been a bold developer, designer, and supplier of high-performance aircraft, such as the F-5 and its legendary B-2 stealth bomber. Northrop teamed up with McDonnell Douglas, their longtime partner on the F-18 program and a dominant fighter manufacturer, supplying the F-4 Phantom and the F-15 Eagle. Always an innovative company, Burbank, California-based Lockheed had been responsible for some of the most brilliant designs in the industry, including the first jet fighter, the P-80, the U-2 spy plane, the SR-71, and the F-117 stealth fighter. Lockheed now teamed up with 2 formidable partners, Boeing, the giant commercial jet manufacturer, and General Dynamics, whose divisions designed submarines and tanks as well as jet fighters. Thomas Jones envisioned a trailblazing opportunity for his company.
From the top, you just send the message, is fellas, innovate, be bold, because only by being bold in your concepts can you be conservative in the detail. That's one of the spirits of Northrop.
That spirit could be attributed to its founder, aircraft pioneer, designer, and innovator Jack Northrop, who launched the company in 1939.
Jack Northrop, as an innovator, was a very creative person. He was like an artist in his field. He didn't have a hard academic background. It was instinctive.
One of Jack Northrop's revolutionary innovations, and one true passion, was the flying wing. His YB-49 would later become the inspirational blueprint for the Northrop-built B-2 stealth bomber. The histories of Lockheed and Northrop have been intertwined ever since Jack Northrop began his career with the Lockheed brothers in 1916. When he left to form his own company, the rivalry began, which continues even today.
We may have had difference in philosophies, but we had respect for each other's technology.
With more than $2 billion at stake, the capital risks were gigantic. 2 proud rivals locked in a contest to produce the most advanced tactical fighter the world had seen, Lockheed's YF-22 and Northrop's YF-23. Directives from the Pentagon were simple, yet required unprecedented advances in technology. First, the advanced tactical fighter had to be more maneuverable than the enemy.
The ability to maintain the turn and burn or yank and bank or maneuverability that Northrop had been so famous for. That's the key element of a fighter aircraft.
The ATF had to fly supersonic without using a gas-guzzling afterburner.
The afterburners are nothing more than a device which pumps a huge amount of fuel behind the engine. Prior to that time, fighter planes would only fly supersonic for brief periods to either catch up with an enemy that they were trying to shoot down or to run away from one that was trying to shoot them down.
The ATF had to be low observable or invisible to enemy radar.
It primarily means building the airframe in such a way that the radar energy that hits it goes in some direction other than the direction it came from.
The ATF also had to be reliable and maintainable in adverse situations.
This remarkable machine could be maintained by a bunch of 18, 20-year-old Air Force technicians out in Europe somewhere or up in the cold of Alaska, with about half of the requirements that an F-15 squadron would take at the same time.
The other directives being met would ensure the final requirement, survivability.
The motivation was to make an aircraft that would allow the pilot to perform his mission with a very high degree of safety, a very high probability that he could return to his family and to his home base in good condition.
The requirements on the F-23 were far in excess of anything we'd designed to in the past.
If we could get the technology for supercruise, stealth, and maneuverability in one package, it would be a quantum leap in fighter design.
We'd had experience in design of supersonic aircraft. We'd had experience in design of using radar systems for detecting the enemy, and from our B-2 program we had the experience of stealth.
You try all of these different combinations until you find just the right combination or compromise that makes it work.
Their job was made even more complicated by the Pentagon's insistence that work would be designated top secret, special access required. Sensitivity to national security required it to be a black program, codenamed Senior Sky.
And a black program, by definition, is like a black hole. And that is that anything that enters into a black hole never comes out.
There were over 45,000 people working on the B-2 in the United States, and nobody knew that they were. Not one.
The best way to keep something secure is to have no one know about it so they won't try to penetrate it.
People who know don't talk, and people who talk don't know.
Del Jacobs was appointed as Northrop's first ATF program manager for the preliminary design phase, and swiftly formed a special team to meet the challenge. Bob Sandusky was assigned as chief engineer and principal architect of the YF-23.
We started this program with just 4 people, myself, my secretary, an aerodynamicist, and a structures engineer.
Drafted from the B-2 division to head the YF-23 technology team was expert physicist Yu-Ping Liu.
Not a day was lost, and we were designing technology for B-2 and ATF together, side by side, daily.
We moved them into a building which had no windows in the walls, no sign on the front of the building. It looked like an abandoned supermarket.
And we put it in the middle of a lot of other production programs, and there was no parking lot, so that a satellite could not see when the program increased its personnel or decreased them.
Just getting through the entrance to the building, getting past the security guards, etc., required special badges, special access.
You were isolated, really isolated, in buildings that had no name and no windows and had double doors.
You go into it for days and you don't know whether it's raining or sunshine outside. Some of us worked for 10 years without ever seeing a window.
One of the characteristics of working in the black world is that the more you know, the more deeply you have to bury what you know.
You would go home in the evening and it's very stifling. You have all this emotion and this enthusiasm and it's trying to bubble out, and you've got this built-in filter that says I can't let it bubble out.
My wife's very understanding. She knows I enjoy my work, and she knows I was involved with something very special because she can tell from my eyes.
She would say to me, "And what did you do today?" And I'd say, "I can't tell you."
Said I was busy building an airplane, dear.
Yet, despite their cloak and dagger secrecy, those working in the black world developed an unexpected camaraderie.
It did make everyone feel that they were a member of a family and became very close-knit, surprisingly close-knit.
Everybody had this common interest, and we felt like we were David taking on Goliath.
Myself personally, I worked 14 hours a day, 7 days a week on this airplane.
For 9 years, I was here almost every day, between 6 to 6:30.
It was the only thing I thought of. I put it in front of my family. I put it in front of everything. I woke up in the morning, I was thinking about the airplane. When I went to bed at night, I was thinking about it again too.
As team spirit flourished, the contest had just begun to take shape.
We knew from day one that we were up against a fierce competitor. Lockheed was and is a fantastic stealth and fighter design organization.
Sandusky's team knew that their design would have to defeat the most potent weapon that can be used against a fighter: radio azimuth detecting and ranging signals, commonly known as radar. Ever since 1940, when it was first effectively utilized by the British against the German Luftwaffe, radar has been evolving into far more sophisticated forms. There is only one way to hide from radar. It's called stealth. Stealth is the ability of an object or weapon to appear invisible to all enemy sensors.
It's the art of deceiving the enemy through either active or passive countermeasures to defeat the sensors that can be played against an airplane.
Top secret research in ways to avoid radar detection has continued for decades. It was Northrop and Lockheed which developed the first experimental versions of stealth aircraft. Lockheed's Have Blue program was the forerunner to the F-117 stealth fighter. Northrop's basis for their B-2 stealth bomber was the Tacit Blue program. This intelligence-gathering aircraft was the first stealthy aircraft with curved aerodynamic surfaces and was developed in a program that was so highly classified that for many years the Pentagon did not even acknowledge that it existed. The two competitors followed different paths in designing their own ATF versions. Lockheed's design followed in the tradition of their Have Blue and F-117 creations with sharply angled surfaces. Northrop's ATF design took on the distinctive characteristics of its stealth heritage, the B-2 bomber.
The B-2 was the most beautiful, technical, state-of-the-art answer to a problem of long-range strategic bombing that I could ever imagine.
The B-2, with its flowing organic lines, radar-deflecting profile, and flying wing design, has a strategic advantage over its opponents. But its specialized ability to handle only bombing missions required the Air Force to demand an ultimate stealth fighter. Throughout the 8-year development of the YF-23, stealth techniques were being continuously tested and refined. One characteristic quality of a stealth aircraft is to have a smooth, unbroken surface.
If it's smooth and flowing and aligned properly, it will be very hard to see.
When you look at an airplane closely, it'll have windows, it'll have access doors, it'll have landing gear doors. Even where large panels of skin meet, there'll be little discontinuities. Those discontinuities are like floodlights when a radar signal hits them.
The shape of the plane was determined by radar and wind tunnel tests. During one type of radar test, the aircraft model was placed on a pole and its cross-section illuminated with various high-frequency radar signals. Its radar cross-section, or RCS, was then measured and the data utilized in the design process. These tests were conducted at night at a secret location in the California desert, under cover from overhead satellite surveillance.
We had a building that was 1 million cubic feet on a rail that housed this airplane during the daylight hours so it couldn't be seen by satellites. Then at night the building rolled out of the way and the radar was shot at the model.
Early in the program, during one such RCS test, the YF-23 first acquired the name Black Widow.
We realized that the radar signature from the leading and trailing edges of the wing and the wing tips formed an RCS pattern that looked exactly like a spider. And I don't remember who it was that said it, but said Black Widow 2. It has to be.
The original Black Widow, Northrop's P-61, was built during World War II. It was a night fighter fitted with the first ever radar-guided gun system, painted gloss black to deflect enemy searchlights.
According to the books I read, it shot down 6 airplanes before the Northrop rep even got down to South Pacific to teach the pilots how to fly it.
Since that time, the Black Widow has become legendary among aviation enthusiasts.
My dad was a supervisor on the first Black Widow, and I was very proud and passionate to be a production manager on the Black Widow 2 in 1990, some 50 years later.
2 separate prototypes of the YF-22 and of the YF-23 were built for the ATF program. These prototype air vehicles were designated PAV-1 and PAV-2. PAV-1 was powered with the Pratt & Whitney engine, and General Electric supplied the engine for PAV-2. The 2 engine companies were locked in their own fly-off competition for engine selection. Their goal, to build an engine that could fly at sustained supercruise speeds.
The noise from the engines during idling was something that you could feel it vibrate against your chest.
The 2 massive engines produced 70,000 pounds of sea-level thrust, which at maximum flight speed produced more than 40,000 horsepower, nearly that of a Navy destroyer.
There was hot gas coming out at something between 3,000 and 4,000 degrees. With that heat, that turbulence, that noise level, you would destroy almost anything else you put back there.
The jet exhaust was also vulnerable to heat-seeking missiles. To lower the heat signature, an ingenious exhaust liner was designed, which cooled engine emissions from detection. The liner tiles, while similar in purpose to those found on the space shuttle, were far more complex and labor-intensive. Each one was meticulously installed by hand.
So many different tiles, so many different techniques we had to do to install it. And it was quite complexing. We're talking several hundred tiles per engine bay.
All the operating functions were controlled by the Black Widow II's unique avionics system.
We developed a new computer technology capability on that airplane that had essentially supercomputers in the air, not in a big building.
The supercomputer, or core processor, performed numerous avionic functions, including radar, navigation, performance data, and situational, or combat awareness. Another important function was flight control. The central computer made the necessary flight corrections as the pilot flew the aircraft, a technique called fly-by-wire.
With a fly-by-wire aircraft, you move the stick and you tell the computer this is what you want the aircraft to do. Pull back on the stick, you want the aircraft to climb. Now, the computer figures out how to make the aircraft do that.
The core processor was the YF-23's central nervous system. It was regarded as the most advanced for its era because it provided all the data in real time, performing an astounding 5 to 6 billion operations per second, compared to an IBM mainframe running at a mere 400 million operations per second.
At that time, we flew an airplane that had more computing capability than probably the rest of the company had in all their large computers.
The development of an airplane is really a packaging problem.
The challenge for the engineering team was to integrate the computer system and its auxiliary components into the Black Widow II's overall design package without affecting its maneuverability, the ability to supercruise, or its stealth signature.
It's the same problem that the supermarket has, and how many pork chops can you put in the package?
To ensure its smooth flowing design, the Black Widow II was actually built from the outside in, which in effect was like building a plane backwards. To reduce the airplane's weight, covering the airframe was a unique graphite-based composite material, lighter than aluminum and capable of sustained supersonic flight. While Northrop pioneered the use of composites, they hadn't been used this extensively until PAV-1. Though Northrop and McDonnell Douglas produced the airframe, they relied on a network of specialized subcontractors who created the internal components, like the computers, actuators, and radar systems.
We got 49 or 50 or 60 suppliers on contract in about 7 months, and a very small group of people did it. And they were late nights. Sometimes we were negotiating with suppliers till 2 and 3 in the morning.
There were now 10,000 people in 30 different states working in complete secrecy on the project. The ATF program was an immense undertaking. Building the plane from scratch generated a massive amount of test data, calculations, statistics, and reports. The paperwork alone was colossal.
And the standing joke was that when the weight of the paper equals the design weight of the aircraft, we're probably pretty close to being finished with the job.
When a fighter is not in combat, it is still vulnerable to natural hazards that could destroy it as effectively as an enemy missile. One single bird flying into a pilot's canopy could result in disaster.
Early in the astronaut program, one of the astronauts was flying somewhere in Texas, and a snow goose penetrated the canopy and killed him instantly. Bum deal.
To alleviate this problem, Northrop turned to their specialist subcontractors. The challenge was to fabricate a specially coated radar deflective canopy, which was thin enough to be optically perfect, yet thick enough to withstand a bird strike at 400 knots. The common method of testing the canopy is to fire a 4-pound raw chicken from a high-velocity air cannon at it. High-speed test footage shows the catastrophic failure when the object penetrates a windshield. But a 3/4 of an inch thick, unbreakable polycarbonate canopy absorbs the awesome forces of impact.
To drill that plexiglass and not to crack the glass was very time-consuming for us. There was no processes that we were using at that time in We had to develop a cooling fluid to do it, and we accidentally stumbled on the soap in the bathroom that worked the best cooling.
Before the assemblies were installed in the prototypes, the major systems had to be tested. This was accomplished with the Iron Bird, a metal frame where the electrical and hydraulic systems could be laid out in exact detail and verified.
We hooked that Iron Bird up to the flight simulator so that when the pilot was performing missions, we came as near as possible to give him the feeling he'd have in the airplane.
At the controls were veteran test pilots Paul Metz and Jim Sandberg.
The pilots were in the simulator developing the control laws, telling the engineers how to design the airplane.
Our job is to be both an engineer and a pilot. We're all trained as engineers.
We're not training ourselves how to fly the airplane. We're working with the engineers to make the airplane fly well.
But Metz faced a problem the first time he operated the simulator.
I went over to the dome and they had a joystick and they said, "Here, fly the ATF." Unflyable. I crashed. First time out.
Metz was to crash 75 more times in the simulator before the design was perfected. Metz and Sandberg, like most test pilots, were a breed apart.
Test pilots are a separate breed, noted for lack of emotion, particularly in high-stress times.
They have to be ready and prepared for any emergency. They have to know the system better than any system engineer. They have to plan for every contingency, know what to do in each contingency.
When something's going wrong, you don't know it. I mean, their voice doesn't change. Their pulse doesn't change. It's amazing. Tend to be a cocky bunch, but I think I'd be cocky too if I was able to do that.
The simulator program was in many respects the most costly part of the ATF budget. Utilizing computer models, the test pilots simulated war games and recreated combat situations, pitting the computerized version of PAV-1 with the best Soviet MiGs and American fighters. And PAV-1 beat them all, hands down. But the success was overshadowed by a new set of problems.
There were 1,500 engineers on the program at that point. At that point, we were spending $1 million a day. So you felt guilty going home and going to bed at night with that kind of money riding on it.
After 3 years, the financial stakes brought new pressures, but the team pushed on.
On the average, I don't think anyone worked less than 50 hours, and many people worked 70 or 80 hours.
I remember it as being like an e-ticket ride. You got on, and once you figured out what you were supposed to do, you really didn't have the time to be overwhelmed by it. You just were in a race.
With 20,000 hours logged in the simulators, the test pilots and engineers felt they were now ready to take their show out to the desert, where new hidden dangers were lurking. 100 miles northeast of Los Angeles, on a desolate dry lake bed, lies Edwards Air Force Base. Home to more historic aviation test exploits than any other test facility on the planet. The base was named after Captain Glenn Edwards, a test pilot killed while flying Northrop's original flying wing. Chuck Yeager smashed the sound barrier here in 1947, and it has also served as test headquarters for the successful B-2 stealth bomber program.
One end of the Edwards flight test facility is a test pilot school, and the whole trick at Edwards is to try to get from one end of the flight line to the other end without getting a street named after you, because if you're killed during flight tests, that's normally what happens. They name a street after you.
In secretive nightly operations to elude overhead spy satellites, huge sections of the aircraft were hauled under armed guard to the base. There, a 125-member flight test crew assembled and tested, while thousands worked in support. 2 days before the scheduled rollout, Chief Engineer Bob Sandusky found a way to give PAV-1 its unofficial insignia. Crawling under the narrow wing space, he came across a sharp edge by the air vent.
I said, you know, that's dangerous, and we really ought to paint that sharp point there red.
Crew Chief Dave Maurice had a can of red spray paint handy.
So I painted the inside of it red so that you'd be able to see it a little bit and try and get a little bit of warning. All of a sudden it turned into an hourglass, like on the belly of a black widow spider.
PAV-1 at last bore the symbol of its namesake. In the early hours of June 22, 1990, the Black Widow 2 was finally completed.
The lead up is always a time of great tension, but now the excitement really starts to build, and we just couldn't wait to have the world see this wonderful thing that we had developed.
But moments before the scheduled rollout, Bob Sandusky was forced to apply some stealth interference of his own when an Air Force general wanted to carry out a last-minute inspection.
And I literally threw my body in front of him and pointed him off to another part of the airplane so he wouldn't see the hourglass on the bottom of the airplane before the rollout.
A few minutes later, the black world secrecy that had shrouded the ATF program for the past 8 years was about to be lifted.
In a few moments, we'll see an airplane that's no longer a paper list of specifications or an artist's concept, but a modern miracle representing the world's most advanced technologies in engines, avionics, and materials.
And now, I am honored, on behalf of the entire team, to present the YF-23, the first prototype of America's advanced tactical fighter.
Although you knew it was a product of man, it didn't feel like it should have been. It felt like something far greater.
For several weeks following the successful rollout, PAV-1 was given a variety of taxi tests. During one of the very first tests, the flaps and tail surfaces automatically began to activate.
The flight control system was sensing the bumps in the tar strips on the taxiway and was really trying to compensate and fly the airplane so it would fly smoothly and not have these bumps in the flight.
The computer's sensitivity was adjusted to correct this anomaly. During the taxi tests, pilot Paul Metz had his first opportunity to experience the aircraft's true capabilities.
That's your first chance to get a feel for the airplane in motion and take a look at the brakes and some of the aerodynamics, what happens when the flight controls, the rudder are activated.
At this stage of the ATF competition, Lockheed had yet to roll out their plane, and Northrop was at last ready to fly. At 3:30 a.m. on August 27, 1990, excited employees congregated in Hawthorne, boarded a fleet of buses in darkness, and headed out to the desert.
We were going to finally get to see it fly, and it was incredible. People singing, having a good time.
Edwards Air Force Base, meanwhile, was a pulse of frenetic activity. Engineers, specialists, and the flight test crew were busy making final preparations for the big event.
The tension just kind of builds and builds. Of course, they're very cautious on a first flight. They're taking time, they're checking everything,
Just before we got in the airplane for the first flight, Paul Metz, our test pilot, came over to me and said, "Is it okay?" That's all he said, "Is it okay?" And I thought back through the thousands of hours of wind tunnel testing, the testing of the composites for their strength, and thought about all of the things that could have gone wrong and some of the things that had gone wrong and we had found and fixed. And I took a deep breath and I said, yeah, Paul, it's okay.
We think that we have checked and double-checked and triple-checked, but until that thing actually lifts off the runway and begins to fly, you're never quite sure.
Go ahead. Roger, we're ready to take the runway. That's 4, wind calm, clear for takeoff. Runway 4.
So pulled out on the runway and did the final checks. I can still remember thinking that 4 years we had been working with those same people, and today was their day as much as it was my day to fly the airplane. That was about the first time I realized that we were really going to do it. So I pushed the power up and released the brakes.
When the airplane took off, it's about as close as a man can come to giving birth, is to see an airplane that you've put so many years into take off and fly.
People just went crazy, waving, just hollering, jumping up and down, hugging each other.
The sound was better than any orchestras. It was the best thing I ever heard.
To suddenly see it get airborne, there's nothing like it. There's nothing in the world.
I was in the control room. I just could not wait. I went out of control. I want to see it fly.
It is just an unbelievable experience. I mean, your heart starts to pound.
I really don't think I exhaled for that hour.
When it passed over was when you see the real beauty of this airplane. That first time was just ingrained in my brain there as an image that'll remain for a long time.
I distinctly remember thinking, this is probably the peak of your career. And as I look back on it, it was.
A photograph of PAV-1's first flight, proudly displaying Bob Sandusky's Black Widow signature, appeared on the cover of the next Aviation Week. In response, orders quickly came from above to have the hourglass immediately removed. As soon as the historic first flight was over, the on-ground celebrations began with a ritual first pilot, first flight soaking of test pilot Mets. The traditional soakings would continue for the 5 test pilots who first flew PAV-1. On August 29, 1990, only 2 days after PAV-1's first flight, Lockheed triumphantly rolled out its YF-23. Now the contestants were dueling wing to wing.
It was clear to us that we had the beautiful airplane. They had a kind of stodgy airplane. And so this led us to believe that we were ahead, we were winning.
Over at Northrop, Jim Sandberg was behind the controls for the first flight of PAV-2. However, this time an unforeseen problem occurred.
After we got airborne and Paul had joined up with me, we raised the landing gear and everything looked good. Paul gave me a call and said everything's up and closed. And then we lowered the landing gear. And the right landing gear never came down.
Stand by, no joy.
So we just talked about it a little bit with mission control. And it was decided that we would raise the landing gear and try it again. One of the few times I ever like to hear somebody say, try it again. We put the landing gear down, they stayed down, and then we conducted the remainder of the flight with the gear down.
PAV-2 safely touched down without any further incidents. Fortunately, Sandberg's pioneering spirit wasn't dampened.
That's the most fun I've had in a long time.
A month later, Lockheed flew their own airplane for the first time. the ATF competition had entered the final round.
We could see that they had made some decisions that were very different from the ones we had made. We felt that ours was going to be a lot stealthier. They, on the other hand, had decided that theirs was going to be more agile, so the race was on.
The agility, speed, and the avionics brain of the Black Widow II met the government requirements. The Pentagon's 10-to-1 force multiplier became a reality.
Well, I think the performance of the airplane is something that is really different about this class of machines. And that sticks in my mind very vividly even to this day. Being able to accelerate out to supersonic speeds and never touch the afterburner.
He's not accelerating me. I'm going burner. Going 240.
I've never flown a better flying airplane, and I don't think that I ever will. This airplane was truly a joy to fly. My favorite recollection of test flying this airplane was a performance flight one day when we had to do some turning performance supersonic. I think it was at 35,000 feet and 1.3 Mach, and I was impressed. So this airplane would really turn well.
For the record, the unclassified official top speed of the Black Widow II at supercruise was nearly 1.5 Mach without afterburner and 1.8 Mach at maximum power. Any speed above that remains classified.
It was really fast. It went much faster than the YF-23. But I can't tell you how fast it actually went.
It was a very fast airplane.
Other performance details are still to this day highly classified.
I don't believe I'm at liberty to tell you.
No, I cannot comment on details, no.
Perhaps the ultimate satisfaction for the team occurred when PAV-1 and PAV-2 made their momentous formation flight.
Seeing two aircraft in formation is an exponential thrill compared to seeing a single fighter. And to see the two coming in together was just beautiful. It's a beautiful scene, it's an exciting scene, it's a thrilling scene.
PAV-1 and its flight test crew now faced one of their biggest challenges, an exercise known as Surge Day. From dawn until dusk, 6 separate sorties were conducted.
Each one of these sorties that was flown was actual test sorties. Airplanes took off, conducted flight tests that we required, whether they were for the engine or for the flying qualities, and then came back and landed and changed out the crews.
All of them very successful, and the airplane stayed together beautifully. It was an extremely reliable and good flying, sweet flying machine.
Fastest ATF in the world, guys.
On April 23, 1991, the Pentagon made the decisive telephone call, identifying which company would recoup their $650 million investment.
A few of us gathered over in Tom Rooney's office. Tom Rooney was the program manager at the time of the announcement.
I was outside the door, and I decided not to get in there because I was afraid I'd be too emotional.
And the call came through.
We got the second phone call, and so we knew at that point that it wasn't us. And of course, that was, the world came crashing down.
Tom Rooney came out, and I saw his face. I knew it's over. So I did not even receive the word. I just left.
It was a very, very sad, very, very quiet moment.
I said, I could not stand that. I don't want to talk to anybody. So I actually cried by myself.
We were crushed. There's just no other word for it.
I went to the beach. I went to Redondo Beach. I was by myself. I walked on the beach for about a couple hours. I was crushed because we knew the numbers. We knew the RCS numbers they accomplished compared to ours, and there's no reason we will lose. So I would not accept the fact. So I was on the beach by myself, pacing down the beach on the sand for 2 hours. For 2 hours, yes.
It was, for me, it was, you know, it was a personal blow. I felt that I had let the team down, and I just didn't want to be around anybody, so I went home.
Absolute disappointment. To this day, I think they made the wrong decision. If the criterion was the best airplane possible for the mission. That's what I believe. Oh, you asked me how I felt? That's how I felt.
Soon after the announcement was made, the YF-23 Black Widow II program was dissolved, along with the hopes and dreams of the Northrop and McDonnell Douglas team that had worked on it. The classified components of PAV-1 and PAV-2, the engines and instruments, were removed, the interiors disemboweled and sealed by the Air Force. All that remained were the empty shells, waiting to be destroyed for the sake of secrecy by their creators.
At one point when they said, well, if we lose, we're going to have to destroy the aircraft, I told them, I said, well, you're probably going to have to find somebody else to chop this sucker up because it ain't going to be me. There's a lot of hard work, a lot of blood, sweat, tears involved in this baby. So there was no way I was going to cut it up.
In winning their respective contracts, Lockheed and Pratt & Whitney would continue the development and production of their YF-22, now called the Raptor.
The F-22 program goes on, and it will be a good airplane.
But ironically, the Cold War became an issue of the past.
The threat that was there 10 years ago when we first started the effort was gone. The USSR collapsed. Russia redefined itself. And suddenly the look-down, shoot-down threat didn't exist anymore.
As for PAV-1 and PAV-2, they remained at Edwards Air Force Base for 5 years, anonymous icons to a lost government contract. Desert denizens collecting dust and memories.
It was wrong to have these wonderful examples of our very best American technology just deteriorating out in the desert.
Because man and machine have for centuries shared an indomitable spiritual connection. On one memorable morning in 1995, Dale Brownlow, Angela Hall, and Gary McNeil traveled to Edwards Air Force Base to bring PAV-2 back home for restoration.
We saw the airplanes with 2 inches of dust around it and cobwebs all over it, birds' nests in it. Pretty discouraging, and we took the wings off, put it on a truck, and moved it down here.
Upon its arrival back in Hawthorne, California, PAV-2 was restored to its former glory by some of the original team who built her. Ironically, the restoration occurred in the same hangar building in which she was first built. PAV-2 can be viewed at the Western Museum of Flight at Jack Northrop Field in Hawthorne. PAV-1 is displayed permanently at Wright-Patterson Air Museum in Dayton, Ohio.
The YF-23 did some things that had never been done before. That legacy is still there for others to use to push on forward.
I think the people, the times, the effort, and the product we came up with was such a team effort and such a coming together of the talents and hearts and souls of so many people that there's a little piece of everybody in that airplane.